All right, I'm not sure where that last one cut off, but I'll just review real fast the last few things in the first video. So let's see, we've got alternate interior angles. They are the same. They were the ones that were inside the two lines and on opposite sides of the transversal. Those angles are always the same. So 1 and 4 would be the same, 2 and 3 would be the same. Corresponding angles are the ones that are on the same side of the transversal in between the two lines. So 1 and 3 are corresponding, 2 and 4 are corresponding. They add up to 180. Vertical angles are ones that if you have two lines that cross, they're angles that are opposite each other. Those are always equal. Adjacent angles are angles that are next to each other. So angle 1 and angle 2 are adjacent. All right, again, we're in Unit 21. So now we're going to be looking at, I would expect that you have your book out. Pause it right now if you don't have your book out. And the expectation is that you're taking notes while watching this, not that you're just sitting here chilling and watching this. I should have probably said that at the beginning of the first video. So pages 478 to 480 are some corollaries. Corollaries are just statements based on theorems. And you should copy all the things in blue boxes to your notes on those pages. So if we just look at them real fast, it says if two lines intersect, the opposite or vertical angles are equal. Well, I just told you that. Basically, it's those opposite angles. They're called vertical angles. They're equal. And then over here, if two parallel lines are intersected by a transversal, the alternate interior angles are equal. So those alternate ones were equal. If two lines are intersected by a transversal and a pair of alternate interior angles are equal, the lines are parallel. So parallel means they're lines that never cross. And then if two parallel lines are intersected by a transversal, the corresponding angles are equal. Corresponding would be the ones that are inside and they're on the same side. They would be the ones that are inside the two lines, but they're on the same side of the transversal. So these are things we'll refer to when doing our examples. Here's a few more. If two lines are intersected by a transversal, and a pair of corresponding angles are equal, the lines are parallel. Two angles are either equal or supplementary if their corresponding sides are parallel. And then two angles are either equal or supplementary if their corresponding sides are perpendicular. So we'll look at some of those when we do a few examples. So our examples are going to come from, first of all, page 477. So page 477 you should be looking at, and we're going to look at number 1. So I'm probably just going to write right here in my book for this. So we're just looking at number 1, and basically all we want to do is name these angles. So name these angles in 3 additional ways. So I'm just going to look at number 1 here. So number 1, here's angle 1, and angle 1, 3 different ways. Well, 3 different ways. You can name it by its vertex, which is angle A. You could name it by 3 sides, or 3 vertices, so BAF. The angle that you're always looking for goes in the middle of the letters. So this could be named as angle BAF, or it could be named as angle FAB. And those are 3 different ways to write angle 1. All right. So now if we jump down to number 13, number 13 says, identify each of the angles as acute, right, obtuse, straight, or reflex. Well, what's a reflex angle? That's what I want to make sure of. A reflex angle is an angle greater than 180 and less than 360. So a reflex angle is greater than 180 and less than 360. All right, so we'll identify those if we need to. So I'll probably look at a couple of these. So angle ACB, so angle ACB is that little angle right in there, that's acute. Okay, if I look at angle CDE, that is a straight angle because it makes a straight line. Angle BCD, number 17, angle BCD, you know, you could classify that either way. You could classify it by this side, obtuse, but I'm thinking they want us to go inside the figure. So this one, I would say you could call it obtuse, Or you could, but since I think we're looking, the real answer that they're looking for is a reflex angle. It's bigger than 180. 180 degree angle looks like this. It's like a straight line. All right, so now let's take a look at, I think that's all we're going to look at here. Okay, so now the next examples we're going to look at are on page 482. So on page 482, we're just going to look at number 1 here. And we're going to refer to the picture here. And what we want to do is determine the values of angles 1 through 5. And this is where we have to use, we've got to use all the corollaries and theorems, the blue things. So we're going to find the measure of angle 1. So the measure of angle 1, if I look at it, I mean, this is a big picture and it can be really confusing, but it's not that bad. So if I just look at angle 1, and what I notice is I've got these two things that cross, and this would be vertical angles here. This angle and this angle are vertical. Okay, and that means they're the same. So angle 1 has to be the same as this angle here, so angle 1 has to be 36 degrees. So I know that one is 36 degrees. Okay, now let's see if I can find angle 2. Well, angle 2 is the same as this angle over here, because these two are vertical angles, so these two are also vertical angles, so angle 2 is 60 degrees 40 minutes. And you can change that to a decimal, you just have to divide it by 60. Oh, but you don't need to. Okay, so now angle 3, let's see, angle 3 is going to be the same as this angle over here because these are vertical. So this angle, angle 3, oops, not angle 4, angle 3 is going to be the same as, here's angle 3 that we're looking for. It's a vertical angle with this one, which is 83 degrees 20 minutes, so angle 3 is 83 degrees 20 minutes. All right, now we're on angle 4, and angle 4 is a vertical angle with this angle over here, so that's 104 degrees. And finally, angle 5 is a vertical angle with this angle, so angle 5 is 159 degrees 20 minutes. So I think that's all we were supposed to do there. So if we were to classify these angles, we could also go through and classify these angles too. So this angle, 36 degrees, is acute because it's less than 90. 60 degrees 40 minutes is also acute because it's less than 90. 83 degrees 20 minutes is acute. And these last two are both obtuse because they're greater than 90 degrees. All right, so that's unit 21. All right, so now we need to talk about unit 22. We're going to talk about triangles now. And with triangles, we've got different types of triangles. We've got equilateral, and in equilateral triangle, all the sides are the same and all the angles are the same. And the way you notify that, or you can write that in a triangle, if they all have the same marks, they're all the same. So, and all the angles are equal to 60 degrees each, and the sides are all the same. In an isosceles triangle, you've got two sides that are the same. Notice these two with the one single marks tell that they're the same. This side would have two marks telling you that it's different. These two angles are the same. So it has the angles that are opposite the sides that are equal, the angles are the same. A scalene triangle has three different angles and sides. So all the sides are different measures, all the angles are different measures. Something nice to know about a triangle is like whatever the biggest angle is, the side opposite that is the biggest side. In a right triangle has one right angle, one 90-degree angle. Has one 90-degree angle. An acute, all angles are less than 90 degrees. So all of them are less than 90 degrees. They're not all the same. Okay, they could be all the same. In an obtuse triangle, one angle is greater than 90 degrees. So a concept that you can use this with is carpentry or building things. And you can make any polygon rigid using triangles. So you take this pentagon here, and if it's just a pentagon and you're trying to build a shape that's a pentagon, like this is the bottom of a roof, if you want to make it rigid, then what you're going to do is you're going to make triangles in here, and put like a truss. You're going to put trusses so they all meet here, and then this is going to be a rigid figure. If you've got a shape like this outer one here, if you want to make this a rigid shape, if you just like hammer, wood together like this or metal, and you try to hold it up, it's going to wobble around unless you put braces in here, trusses, and you're going to make triangles, as many triangles as you can, and then that will hold its shape that you want. So you'll be asked to redraw some things and put things in there. All right, so I don't know that we'll get to page 490, number 4. Let's see. Basically, a problem like that, page 490, number 4, we're just identifying each of the triangles as right, acute, or obtuse. So if I look at triangle A, since this angle is greater than 91, this one would be obtuse. And this one, if these two are 66 and 24, well, we haven't really learned this yet. This will be the next theorem we learn. The sum of the angles of any triangle is equal to 180. So I don't know this angle here, so I know that these all have to add up to 180. So I'm going to take, on my calculator, take 180, because they all have to add up to that, subtract 24, and then subtract 66 and see what's left. Well, that one has to be 90, so this would be a right one, a right triangle. Okay, I'm just going to move to D. All the angles are 60, so this is equilateral. And I think that's an example of each of them. So now, if we do know that all the sum of any angles of a triangle add up to 180, we can use that to figure out missing angles. So if we just take a look at, just slide right over here to this page. This is page 491. And if I wanted to find some of these missing angles in here, I could use the fact that all the angles in a triangle have to add up to 180. So I know this is 90 degrees, and this is 90, and this is 43, so I should be able to find that angle. Okay. Another angle I should be able to find, since this one is 90, this one has to be 90, because these two angles make up a straight angle, and so that one is also 90, so I should be able to find that angle. So let's just see if I can find, all we need to do is find this angle right here. So in order to find that, I'm going to need to find this angle. So to find this angle, I need to find this one, and then I know that these three, this one, and this one, add up to 180. So the first thing I'm going to do is find this angle right here by taking 180 minus 90 minus 43. So 180 minus 90 minus 43 is 47. So this angle down here is 47 degrees. This angle then, if I take 180 minus 47 minus 58, I get that angle in there is 75 degrees. So now these three add up to 180. So then I can take 180 minus 75 minus 64. And so the angle we want, angle 4, is 41 degrees. All right, so now the next thing that we have here, I think that is all. Oh no, we've got a few other theorems that we have to talk about here that you need to look through the theorems on and write them in your notes from page 494 on isosceles and equilateral triangles. And on page 496 is probably the most important one, the Pythagorean theorem. And that's the one I'm going to do an example of right now. So the Pythagorean theorem says that if you have a right triangle where the right angle is, they usually call it angle C. The side opposite that is called side C. So then you've got angles A and B, and the sides opposite are the names of the sides. The Pythagorean theorem says that if you take the sides, you square the two sides that are not opposite the right angle and add them up, that's equal to the long side squared. These are called legs, and this long side, the side opposite the right angle, is called the hypotenuse. So that is all of Unit 22, and the last video will have Unit 25, or 26, sorry.